9 from the test review, the Chapter 7 test review. So let's just kind of give a context for this first of all. So we're looking at a velocity function, and it's measured in feet per second, and it's of a skydiver. So here we have dv dt, which is our derivative of the velocity with respect to time. And I want to, in part A, I need to figure out what is the velocity function. So I want to solve this using separation of variables. So the first thing we need to do is kind of get all the v's to one side with the dv and all the dt's to the other side. So that ends up looking like this. And now I need to take the antiderivative of both sides. So I basically need to integrate both sides of this equation. So I'm just going to throw an integral sign on both sides of this. Notice that on the left side, we kind of have to do a mini U substitution. I call it mini because if I find du, it's just going to be 1 dv, which is really nice. So then my integral is going to be -1/2 natural log of u, which is equal to t plus c. Okay. And then I'm going to go ahead and plug my v's back in. Okay, so I think most of us were able to get to this part, hopefully. This next part is when it gets a little weird. So a lot of the ones that we've been doing in class, we've just stopped at this point because we've now found an equation that relates our v and our t together. But in this problem, it specifically asks that I want to find an expression for v. So I need this to be in a v equals format. So I'm going to go ahead and start by working to get this v by itself. So I'm multiplying both sides by -2 to get rid of the 1/2. And now to get rid of the natural log, I'm going to raise both sides to the power of e. And that just turns into v. I did. Thank you. That turns into v plus 17 is equal to e to the -2 minus, oh, I just changed that t to a c for some reason, minus 2c. Okay, now I'm going to do some exponent rules on the right side. So since I'm subtracting, I could think about this as adding two exponents together. I can separate this into the multiplication of e to the -2t times e to the -2c. And then I'm going to kind of zoom in on just this e to the -2c piece. Notice that c is just a constant, right? We haven't decided what that constant is. We really don't know what it is. So what I'm going to do is I'm just going to relabel that as a new constant a. And we're just going to let this be a new constant. So now my expression looks something like v plus 17 is equal to a e to the -2t. Okay. Now I'm going to go ahead and solve for v. So v is equal to a e to the -2t minus 17. Okay. So this looks great, but now I need to solve for a, right? So remember, a is still a constant. It's like solving for the c. Now our constant is just called an a. And we need to solve for that a. We've got to use this initial value it gives us. So v of 0 is equal to -47. Is it negative? Yeah, -47. So I'm going to replace the v with -47, my t with 0, and I'm going to solve for a. I'm going to add 17 to both sides, so I get -30. And then this is going to be e to the 0 power, which is just 1, so that's just going to give me a. So now I can get my final equation here, maybe. V of t is equal to -30 e to the -2t. And that is going to be my final expression. And that's an expression of the velocity function with respect to time. So that's part A, which was probably the trickiest part. I think that's where most of you guys are getting caught up. Let's go ahead and take a look at how we would work through parts B and C. So I'm just going to kind of do it on the other side here. So part B, it wants me to find the terminal velocity, which means that I want to find the limit of my velocity function as time goes to infinity. So the limit as t goes to infinity of my velocity function, negative 30 e to the negative 2t minus 17. Now I'm going to rewrite this function really fast because I have a negative exponent, which means that I could bring that e to the 2t to the bottom of my fraction and keep it and make it a positive exponent. Now, if I think about this function, and as t goes to infinity, the denominator of my fraction is going to get really big, so this whole fraction right here is going to go to 0. So my limit is equal to essentially 0 minus 17, which is negative 17 feet per second. That's my terminal velocity, so I'm not going to be going any faster than that. And then the last part of the problem says we know it's safe to land if my speed is 20 feet per second. So I want to know at what time do I reach this speed. So I'm going to go back to my original velocity function. Let me just get that written down here. And I've got to find the time when my speed is 20. So speed is related to velocity, but let's remember that the difference between speed and velocity is that speed is always positive and velocity can be negative. And in this case, our velocity is going to be negative because the skydiver is going down. So my velocity is negative 20, e to the negative 2t minus 17. And then I'm just going to solve this equation. I'm going to add 17 to both sides. Divide both sides by 30. Take the natural log of both sides. Divide both sides by negative 2. And my t is going to be approximately equal to 1.1513. Okay, so that's how long it's going to take for the skydiver to reach a speed that's safe. So lucky for her, if you think about this, she's only going to take 1.5 seconds to get to a place where she is safe to land. Unfortunately, she's not going to reach the ground at 1.1513 seconds. She's going to keep falling even further. That's why the parachute comes in, right? Because if she just kept falling, she would hit the ground at a lot quicker pace.